Hi everyone, Dennis Foley from Acoustic Fields. People have been asking a lot about our technology, especially our carbon technology, and they hear different words: perforated, diaphragmatic, Helmholtz, membrane. So I'm going to kind of clarify a little bit about what we've done here, because it's never been done before to our knowledge, especially in a commercially viable product. So what we have inside our whole ACDA series, QDA series, is a perforated absorber inside a diaphragmatic. If you look at a top view of the cabinet, this is the cabinet, and then inside is a perforated absorber. And this is a diaphragmatic absorber. So we have a perforated inside a diaphragmatic. The way to think about a perforated absorber, same way you think about diaphragmatic, except think about the face as pegboard. It's a series of holes, okay? Each hole, the neck is kind of a Helmholtz resonator. So if you look at the pegboard, it's got all those holes, right? Well, each one of those is, if you look at the side of the cabinet, the neck of an individual resonator. So that's where Helmholtz gets his concepts from. So there's your formula. F, of course, frequency that you're after or designing for. Perforation percentage is P. Hole length, depth of airspace, and then the square root of all that. Okay, 200 is a constant. There's mathematical reasons for all this. It doesn't matter. This is the formula. They're usually good in the 90 to 200 hertz range. And 2 to 4 inches in depth. I've seen them a little bit deeper sometimes, but it just depends on, obviously frequency and amplitude in the room. So that's a perforated absorber. Diaphragmatic formula is a little bit different. Frequency, of course, 170 the constant versus 200 there. But here's the thing: density, mass, and depth. Square root of that as the denominator. 170 the numerator and a constant. So you can kind of see the relationship. I don't want to go into it right now. It takes too long to explain. But I think if you compare the two formulas, you see. So perforated absorber inside of diaphragmatic. So if we treat the diaphragmatic absorber as a small room, it's going to have a certain frequency of resonance. We know that by its depth. It can be calculated. So then you want to design the perforated absorber to work with that frequency of resonance inside your diaphragmatic, which is a small room, right? Everything's a small room. It seems like subwoofer cabinets, speaker cabinets, rooms, vocal rooms, everything's a small room. So 90 to 200, depth 2 to 4 inches. Diaphragmatic a little bit different, more horsepower. So you increase the density, the depth to a certain point. The depth determines how low it's going to go. That's why we need 12 inches on our technology to get to 30 cycles, sometimes 16, depending on the situation. And the density of the cabinet, how heavy it is, how much does it weigh per square foot. And then what we did on the front, we put two walls that are out of phase. So you got your, if you look at it from the side, this is wall 1, wall 2, this is the perforated absorber, and that's all wrapped in a diaphragmatic absorber. So that's our technology, and that's how I came about it. So both the ACDA series and the QDA series. Of course, the ACDA series is 30 to 50 for the 12, 30 to 300 strong for the 10, more broadband. And then the QDA series is our top-of-the-line product with both carbon, absorption, and diffusion in one product. All handmade, beautiful products. We're going to have some project pages coming up with these 23s that we built for clients. Just look at how beautiful these things are. They're quite amazing. They're big, 42 inches, 42 and a half inches wide. Look at the performance of our ACDA 12. You won't find anybody's product in the marketplace that performs that well. Look at 30, 40, and 50. 100% at 50. 63% at 40 and 30, 35. I think we even get a little bit more. Very powerful sponge, and that's what you need in all small rooms. That 30 to 50 in every room. I don't care what you're doing in it, except voice. Perforated inside a diaphragmatic. That's the process we use. I hope this helps clarify things a little bit. Thank you. Thank you for watching this video, and if you liked it, please give us a thumbs up. We also have a newsletter that you can subscribe to, so please do that because we offer special price discounts to only those on our newsletter. And then don't forget about our forum. We have started a forum on our own website where people ask questions, and I usually get a chance every couple days to look at it. There's an interchange between people on the forum, and we'll give you real answers on a regular basis, so that'll help you. Thank you.